Hello, today we will continue our previous video on this chapter 10 circles. Now today we will discuss from question number 5. But before to that, some rules are there that I want to again reiterate for you. You have to keep this in mind. Means no tangents lying inside a circle. Means suppose it is a circle. So tangents will be at a point. At a point it is always there. It is at a point. Means tangent cannot go inside. Suppose it goes inside, slightly inside it goes. Then it will become secant. Okay. It means at any one point only one tangent is possible. At any one point only one tangent is possible, because the next tangent will go inside that. It will come inside. It will come inside, and if it is inside, it becomes a secant. Okay. Here this concept is only one tangent on a point lying on the center. Only one point. At one point only one tangent is possible. More than one is not possible. If more than one are coming, these all will be inside, and so all will be secant. Okay, this is clear. What is tangent and what is secant? Now exactly two tangents to a circle is possible from a point outside the circle. Means suppose a circle is there and outside any point is there. From this point only two tangents are possible. From here you can draw only two tangents. Now next tangent is not possible because it will go inside and become a secant. So secant here is not possible. In the same way, if from here, from a point, if you draw to this side also, only one point is possible. More than one point is not possible. So from one point only two tangents to a circle. From a point outside the circle, only two tangents are possible. Okay. The fourth one, tangents are equal from an outside point to the circle. Means this tangent, it is a tangent, and this is also tangent. This tangent, this side will be equal to this side. From a point, only condition is there, it should originate from a particular point. If from a point if it is originating, then this AB and AC will be equal. Then fifth is center lies on the bisector of angle between the two tangents. Between the angle means inclined position. Okay. So two lines are inclined. Inclined means this line is inclined to here, and this side is inclined. This line is inclined to this side. So this is angle here. This is the angle. This angle, if you bisect it. If you angle and bisect in this angle, if you bisect it, what will happen? It will pass through the center. Now another point 5, we are taking the tangents at any point of a circle. Suppose it is a circle. At any point we are taking, suppose this point we are taking tangents at any point of a circle. So this is any point of a circle. This is tangent. Okay. Of a circle is perpendicular to the radius. Means from here, if you draw a radius, this is your radius and this is your tangent. So tangents are at a point. This is a point on the circle. This point, the tangent at any point of a circle is perpendicular to the radius through the point of contact. This is known as point of contact. Okay. So tangents are always perpendicular on radius. Okay. Now we will rub it and we will start with our question number 5. Okay. Now question number 5 we are taking. In question number 5 we have to prove. What we have to prove? Perpendicular from a point of contact. Perpendicular from a point of contact. This is point of contact and this is the perpendicular, means 90 degree. Perpendicular from the point of contact to the tangent. This line C is your tangent line. This is your tangent line. Okay, and D is the center. D is your center point. Okay, to the tangent to a circle passes through the center. What we are saying, if a tangent is there and from a point of contact, B is point of contact. From this point, if you draw from a point of contact, if you draw a perpendicular, means on point B, if you draw a perpendicular. So we have drawn this we have drawn, okay, BD a perpendicular we have drawn. So it will pass through the center, only this you have to prove. So to prove this, we are taking, suppose it is not passing, so that's why we have drawn another line naming D dash. BD dash, we have drawn this, and now we are going to do. So as per the condition, perpendicular from a point of contact. So from this point we have drawn a perpendicular on line on this tangent, and it should be 90 degree. It should be 90 dBc because tangents are perpendicular on the radius. So it should be a perpendicular, and angle DBC is also 90 degree because in the question it is given that it is a tangent, it is a perpendicular. So perpendicular means 90 degree it is drawing. So here also it is 90 degree. But the figure, you see the figure drawn does not support it, but the figure drawn, you see whether this is 90 degree or this is 90 degree. Anybody can tell this is not 90 degree, only this line DB line is showing that this is not possible. This is not possible by seeing the figure. So radius DB is not perpendicular. This is not perpendicular. Radius also we cannot say, the line we can say. So line DB, this is DB, one line is there. Line DB is not perpendicular. Hence only DB, this DB, hence only DB is perpendicular. DB is possible. Perpendicular, that is 90 degrees, and perpendicular passes through the center, and the perpendicular will pass through the center, not pass through any point in the circle. That's why. So to prove this, what we have done, we have constructions we have done based on the question. You have to write construction. Drawn a circle with D as a center and tangent AC we have drawn. B is a point of contact we have drawn. Join center with B, join the center with the P. Drawn DB also, or joint you drawn. This is line drawn. Okay, this is drawn D dash B also we have done. So in this way it is proved. Now question number 6 we are going to do. So now we will start with question 6. In question 6, you have to find the radius. CB, radius you have to find, length of the sphere. So what constructions you have done, I will not write, I will just explain, and you try to write by yourself. Make practice. So in the constructions you have to write, we have constructed a circle with point C. Circle with a center C. We have drawn a perpendicular BA with 4 centimeter and join the center with a point with A with its length is 5 centimeter we have drawn. So this BA will be perpendicular on this radius. Suppose the radius is there, so CB is your radius. BA is tangent. So BA tangents are always perpendicular on radius. It is one theorem is there that proves it. So when it is perpendicular, it means angle B will be 90 degree. Okay. So this we are taking. So angle CBA is 90 degree. And triangle TCBA is a right angle triangle, and if it is a right angle triangle, our Pythagoras theorem applies. Pythagoras theorem applies that perpendicular, this line, this radius is known as the perpendicular in Pythagoras, and this line is known as the hypotenuse, and this line is known as the base. Line is as the base. So perpendicular square is always equal to the hypotenuse square minus base square. So here BC is the your perpendicular, hypotenuse is CA, and BA is the base. So BC will be, if you remove this square, it makes the root of the other side, RHS side. So BC, now we have put the figures, 5 centimeter and 4 centimeter, we have put it here. That is equal to 9. So BC is equal to under root 9. And 9 we have made a prime factorization, 3 into 3. So for this root, it is second root. So pair of 2 items you have to make. So this pair, only 1 item you will take, and this root sign will go out. So BC is equal to 3 centimeter, and that is your answer. Okay. So question 6 is over. Now question number 7 we are going to do. So question number 7. In question number 7, you have to find the length of the chord. Length of the chord name we have given, but question it was not there. Name of the chord of larger circle. So here concentric, 2 concentric circles are there. Concentric means whose center is same. 2 circles are there whose center is same, so it becomes concentric. Concentric circles means a circle, this is a circle, and with the same radius, if you draw another circle, it is concentric. Okay. Circle I could not draw properly. So this is one circle and this is a, so it both are concentric. Okay, concentric circles which larger, so this is the larger one. Here larger circle is your this outer one, this is larger. This is larger. By figure you can see this is larger, and this one, this is smaller circle. So what is a which touches a small circle at a point C? AB is a chord. AB is a chord of larger circle. In the larger circle, AB is a chord. Chord means any line which, suppose this is the line. So this is chord, and it passes through, then it becomes secant. If it is within, it is a chord. Okay, this is now chord. CHORD, chord. This is a chord, so this is your center. This is chord. So this larger circle's chord touches the small circle at point C. What you have to prove? This you have to prove. Larger circles, the length of length you have to find out. The length of the chord. This length of the chord means A to B you have to find. A to B you have to find. And AB is made of AC plus CB. So first we will find the CB and then we will make it double. Okay. So it is given AB is a chord, 2 concentric circles are given, AB is a chord given, radius DB equal to 5 centimeter, and DC your perpendicular, DC is given as the 3 centimeter. So CB base will be equal to the hypotenuse minus base. So Pythagoras theorem we have used, Pythagoras theorem we have used here, and as per that, so this will be 25 minus 3 power 2. So 25 minus 9, it will become 3 power 2. It is 3 power, not 32, 3 power 2. So 3 minus, it will become 16, and as CB we are finding, so it is under second root. So we will make prime factor of 16, 4 into 4. So in the pair we will take only 1, because when the second root is removed, 2 pairs, for 2 pairs we take only 1 item. So CB equal to 4 centimeter. You have find out this is 4 centimeter. You have find out. Now we know AC and CB are equal. As AB line, this tangent is always perpendicular on the radius. That is a theorem. So AC and CB, it will be 90 degree. It will be 90 degree, and it is and AC CB, because this BC line is made of the 2 points, AC equal to CB. So AB equal to AC plus CB, and in place of AC, because both are equal, we can, in place of AC we can also write CB also we can write. So So AB equal to 2CB. Why CB we have made? Because CB we have proved here. That's why AC we have changed to CB. So AC we have changed to CB. This AC we have changed to CB. This AC we have changed to CB. Okay. So 2CB is equal to AB. So AB equal to 2 into 4 centimeter equal to 8 centimeter. That is your answer. Now question 7 is over. Question 8 we are going to do. Question at 8, what it says? A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. You have to prove it. So what is given? A quadrilateral ABCD, AB, C and D is given. Circumscribe circle Q. This circle Q is within, circumscribe means within anything. So within this quadrilateral it is there. So we know that from a point, from any point, from suppose this point first we have taken, from a point A, this AO and PA will be equal because as tangents from a common point for this and this tangent, this common point is A. From a common point to the center, a tangent to the center are equal. We know it. That's why from point A, two tangents are there. One is AO and one is A and P, and this is the common point. So AO will be equal to PA. AO will be equal to PA. Similarly, from here you see, from point B, OB is drawn. OB is drawn and BN is drawn. So BO will be equal to BN. BO will be equal to BO. BO will be equal to BN. This is similarly from point C. Point C you see that from here to here MC is there and it will be equal to CN and it will be equal to CNN. Similarly from point D, this DM is drawn and this DP is drawn. So DM will be equal to DP. Now if you will add, suppose we add all these, this side equal to this side. Suppose it is RHS and this is LHS. Okay. So LHS is equal to, so if we sum all that, so what we will get? A plus BO, MC plus DM, and this side PA plus DP plus BN and CN. Okay, this side we will go like this. So in place of AB, AO plus B, AO plus OB is equal to full line AB. Likewise MC plus DM, this MC and plus DM, if you add it, the full line is CD line is coming. Then in place of here PA plus DP, so PA line, PA plus DP, if you make the line becomes DA, AD or DA it becomes. Here in this side also BN and CN. So this is BN and this is your CN, BN and CN. If you add both the lines, line becomes your B and C, line becomes B and C. So here you see when we have these lines. Now in place of AB we have written, CD we have written, AD and BC what we have said that we have written, and this is the question you have to prove. So you have proved it. Now instead of doing question number 9, we will go to question number 11, because question number 11 is also the similar thing. Okay, so with the help of this we will try to solve question number 11 also. Now we are going to do question number 11. You see it is similar question as we have done in the previous. So whatever is written in the blue, it is from the previous questions and we have already explained these things. Okay, now only question I am reading. Question: prove that the parallelogram circumscribe a circular is rhombus. We have to prove. Rhombus means any quadrilateral which is like, which all sides are equal, but it is like all sides equal. So rhombus is a square, but its angles are not 90 degree. In a square, all sides are equal, but angles are also 90 degree. That is your square. But in case of rhombus, this 90 degree will not be there. Lines will be equal. All four lines will be equal, but angle will not be. It is not 90 degree. It is not 90 degree. Okay. So that you have to prove. So here, what is given? A parallelogram ABCD is given, and here AD line. Because parallelogram, so lines will be parallel. So AD. This AD line is parallel to your BC line, and this AB line will be parallel to your, means this line is parallel to this line. Okay, these are the parallel lines. Okay, so these are the parallel lines. And AD equal to BC, this, and I told you as it is a parallelogram, so here AD will be equal, and in this parallelogram AD is BC and AB equal to CD. AD equal to BC means A and D, this line is equal to BC, and AB line is equal to your CD line. It is. Now in the previous question we have the blue, we have written here blue and black. This we have already discussed in our previous video. Okay, in the previous video we have discussed. So up to this position I am taking it from the previous video. You can from the previous question, not video. Up to here you are up to here. Now in place of AB, it is given AB equal to CD is given. So in place of AB we can write CD, and CD we can write. Similarly here you see AD equal to BC. So in place of AD we can write BC also. So this and this we have replaced based on this. It is given. So here 2CD equal to 2BC. Now 2 and 2 you cut off. What will remain? It will remain CD equal to BC. So one thing we have proved in parallelogram, in this parallelogram CD line, this line CD line, this line is equal to your B and C line, DM, and this BC line we have proved these two lines are equal lines, CD and BC are equal. Now in the same way, similarly we will prove this line equal to this line. I will rub this portion and prove it. Okay. Now, up to here, in the previous lines, we have proved it. Okay, in the previous lines, we have proved it, and in previous question also, we have proved up to this level. Up to the blue line, everything is proved. Now, in place of AB is equal to CD. So we can replace CD with the AB. So we have replaced CD with AB. And in the other side also, AD is equal to BC. So BC we have replaced with AD word. So now 2AB is equal to 2AD. So AB will be equal to AD. Now AB line, you see, this is your AB line. This is your AB line, and if you plus it, AO, AB line, this is AB line, and the other is AD line, this is AD line. So this and this you have to prove AB line and AD lines are equal. So this line and this line is equal, this line and this line is equal. So what AB is equal to. So now I will rub it, and from here onward I will do the question. So from here onward, now we are coming to the question from the last line. So last line was AB plus AD. AB is equal to AD. And in the previous lines we have also proved CD equal to BC. Now AB is equal to AD and BC is equal to CD. But this side and this side is equal due to parallelogram. In parallelogram it is always equal. That's why it is equal. These two sides will be equal. As all sides are equal, now all sides are equal, four sides are equal. As all sides are equal and not right angle, it is all sides are equal. All sides are here equal. This side and this side is equal. Means D and C, A and B. So all four sides are equal, but here it is not 90 degree. Here it is not a right angle. They are not right angled. So quadrilateral ABC is a rhombus. Rhombus means all the, it is like a square, but angles are not 90 degree. That's why it is rhombus. Okay, now it is proved. Now question number 10. Question number 10, it is saying prove that the angle between two tangents. Here angle between two tangents. This is one your tangent and this is also one tangent. And the angle between here, it is saying. So that the angle between two tangents drawn from an external point. A is external point here. A is external point. From external point. So two tangents are drawn from an external point A, AB and AC. External point to a circle is supplementary to the angle subtended by the line segment. Here this is the line segment. This is a line segment and it is joining. It is not necessary it should pass through the center. Any line segment, see this BC is a line segment. The line segment joining the points of contact. C is point of contact and B is point of contact. Not necessary. Suppose your point center is here. It may be center here also. The line segment which joins the point of contact. Point of contacts at the center. Oh, at the center it is. It is at the center. It is written in the question. It is written here. So angle BAC is supplementary to the angle extended at the center. In this center, what this angle is extended. So center, that is BDC. So they are supplementary. So you have to show BAC means this triangle is supplementary to the angle extended at the center. D is the center. D is your center. At the center. D is your center. It is your center. So this angle extended at the, you have to prove this and this equal to 180 degree. This you have to prove. So now we know how we will go. We know tangent AC is perpendicular on radius DC. On this radius it is tangent. Perpendicular, and AB line, this AB tangent is perpendicular on radius BD. Now in quadrilateral ABCD, now we are taking ABCD, this quadrilateral. So here angle ABCD will be equal to 360 degree because it is angle sum property of quadrilateral. Now in place of whatever we know B is perpendicular, so 90 degree angle it creates. Perpendiculars always create a 90 degree. So here 90 degree will be there, it is also 90 degree. So B and C will be 90 degree angles. D we don't know. So here these together we will transpose to other side. So this equal to 180 degree. From 360 degree we will reduce 100 degree. What will remain? 180. This side, this has gone, so angle A and angle D will remain. So angle A and angle D is equal to 180 degree. In place of angle A, we can write the three letters also, BAC. BAC, that is angle A, and in place of angle D, we will write BDC, that is angle D, angle A and angle D. So angle A we are proving and with angle D. So equal to 180 degree. So these two angles total is 180 degree. So they are supplementary. Supplementary means equal to 180 degree. So in this way our this video is complete. Now rest of the questions we will cover in our third part also of this chapter. Thank you for watching. Please share with your friends and subscribe to my channel. Thank you.